Right, so thanks for, well, basically showing up, everyone. So what we're going to talk about is the PuppetDB API. So my name's Danny, as I was just introduced. Officially, I'm Daniele, which gets extremely confusing in every country except for Italy, because I'm a guy, but my name looks like I'm a girl, which is fantastic. And yeah, it's like great. It's like you even fill in the forms and you say like Daniele Sluijters, and it's like I'm a guy, and you get the email back, dear Mrs. Oh goddamn. It's just how it goes. I've been with Nedap for a couple of years, and I started out as just someone writing modules and manifests for them. And little by little, I got into the more complex things. So one of the things that scares me to death is Ruby. So whatever I build and have done on top of Puppet is actually always been in a different language. In the case of Puppetboard, and whatever I do with the PuppetDB API, it's been done in Python. Yeah. So the major thing about PuppetDB is it's data. It's data. It's a lot of data. And you can use it to do a lot of really cool things and integrate with a lot of different systems. But I get the impression that most people haven't actually either thought about it or tried to pull this off. So the basic premise of PuppetDB is we store a crap load of data about your infrastructure. I don't know how many people were at Deepak's talk earlier today about what we talked about, like 5, 6, 7? Yeah, OK. So he showed a bit of the things that have been happening in the PuppetDB space. But as a basic introduction, PuppetDB stores information about your nodes, about the facts that are associated to that node, the environments that this node shows up in, resources that are managed on this node. We have the complete catalog that we can get access to if you want to, reports, just about anything, really. There's a lot more data in there that you can humanly need or whatever. And PuppetDB is pretty awesome. You can do a lot of really, really cool stuff with it. And it's also, it works remarkably well. It's this thing, you just install it, you deploy it, and there's a lot of people, including me, when we started, that was extremely skeptical about having to use a service that runs on the JVM, especially because everyone goes like, oh, no, but it'll eat all my RAM, and it will print me XML stack traces. And it does that sometimes. It really does. But it does a really good job of trying not to blow up on you. And that's extremely important when you have a service like that. So about a year ago, I walked into our office on a Monday morning, and our DBA came up to me, and he kind of walked up to me, and he stood there with this half-evil smile. And whenever your DBA does that, it's never a good sign. It means something happened, and he's likely to blame it on you, but he kind of wants to see if you can figure out what's going on. So he kind of kept staring at me, and I was like, yeah, sure. What do you want? He's like, remember this Puppet dashboard thing that we have? I'm like, yeah, sure. Like the old dashboard that I don't know how many people use or remember, but that one, the one that Puppet Labs used to maintain. Well, you store a lot of data in that thing. So essentially, especially, whoa, no, doing that. Stupid thing. And because you store a lot of data in a thing, and it doesn't have any kind of deduplication logic or any of the other smart stuff PuppetDB does, the disk space kind of grows and grows and grows and grows and grows and grows. And that famous Monday morning, when I came in, the disk space was gone. So we sat down and we looked at it, and essentially in about a month, that thing had managed to eat through at least 12 gigs of data, and we were talking only about 100 of nodes. So we figured this is stupid. We've got PuppetDB, it's already containing all that data. I have no idea why we're also shoving that into a MySQL database that's doing a far worse job at it, and we're not using it. So looking at the PuppetDB API, we came up, why is it doing this? Huh? Maybe, but which one?
No, just unplug it. Just use your laptop.
Oh, right. That's a good idea. And everything will die in just a second. Ooh, still works. OK, so what we came up with is this thing that we call Puppetboard. It's a Python web app. It's built in Flask. It has all kinds of nice kind of features. And I won't actually demo this thing, but essentially, the only thing it does is talk to the PuppetDB API. It doesn't have a database on and of its own. It doesn't really do anything fancy except for use an HTTP request to get some data from PuppetDB and essentially render it on a screen. So this is the overview page of it. As you can see, I've been gone for 2 days and we already have 6 nodes failing. So that's bloody brilliant. And we have about 142 nodes in our current infrastructure. And you get some basic metrics, like the average average resources you manage on a node, how many resources you manage in total, and so on. And it basically gives you an overview of machines that are there and what their current state are. Ideally, the second part of the page is just blank. It means nothing is changing, everything is absolutely perfect. Obviously, not very much the case. So whenever you're trying to work with the PuppetDB API, their documentation is like your Bible. It's the holy grail of HTTP requests in this case. I use the short link here over there, but this essentially points to docs.puppetdb/puppetdb/latest/something more and more and more. But it's got extremely extensive documentation about the PuppetDB API, how it's structured, what you can query, and what you can expect back, all kinds of operators that are supported on top of the API. Essentially everything you need to know to be able to get data out of PuppetDB or sending commands to do stuff. Because besides the fact that it's a storage thing, you can also destroy data. You can tell it to delete a node. You need to be careful when you do that, especially when you happen to be developing against a production database. So essentially, what does the request to PuppetDB endpoint look like? It's really basic. You get the endpoint. An endpoint in PuppetDB is, for example, the nodes endpoint, which gives you information about a node. The facts endpoint, the resources endpoint, the metrics endpoint, which can basically get you all kinds of metrics from through JMX and a few other means so that you can get an idea of how your PuppetDB is running. We have the resources endpoint, as I said. We've got the reports and events endpoints. We've got a bunch of aggregate endpoints, which are a bit weird but extremely useful, but you need to wrap your head around it in different ways. And version and server time. I've never actually had to use server time, but yeah, you can ask the thing what time it is. If you need some kind of custom NTPD implementation, that one will do wonders. The second part is the rest of the path. So we kind of distinguish between endpoint, which is like the sort of type of entity you want to query, like node, fact, resource, catalog, and then there's the rest of the path. For example, nodes/hostname if you're targeting a specific hostname. And then you have an optional query, which you wrap in, which essentially is an abstract syntax tree that you're trying to write. This is extremely annoying, and it's one of the reasons I've highlighted it here on the slide. The AST is very, very good for human or for machine format because it's an AST. It literally is extremely easy to transform that AST that you get into the closure code to just basically apply the thing on the data set and get out what you want. But it's not very human-friendly. Fortunately, Eric Dallin from Spotify wrote PuppetDB Query, which is sort of an abstraction layer on top of it, which has a far more human syntax and essentially generates the AST for you. And as Deepak said, they're actually kind of looking at using that language or a derivative of it so we can get rid of the AST query. So the basic thing, nodes/hostname. If you want to know anything about a node, you take the nodes endpoint, you shove the hostname. It's not actually the hostname, it's the name in the certificate, what we're calling the cert name. Put that in there, and you get stuff back like, when did we upload your catalog? What environment are you in? When did we upload your facts? When did we upload your report? And one or two other things. If you want to get a bit more complex, you can do this. This goes to the nodes endpoint, so it will return you all the nodes, but it tries to strip it down to only nodes which have their catalog environment set to production. So let's say that we have production, testing, development, and something else environments. This basically gives you all the nodes from your production environment. You can also do far more complex queries, like far deeper queries which nest and take data out of it. And there's very, very good examples on the PuppetDB documentation. I've never really had to use them, especially not in the state for Puppetboard, because it's a fairly simple overview. But if you want to do like data crunching and start putting relations between things, then you definitely want to look at what you can do with the AST query. If we dig a bit deeper down, you can just go nodes, hostname, and then facts, which will return all kinds of facts for your endpoint. Fun thing is, you can do this exact same query by going to /facts and then putting an AST query of equals cert name hostname, or the hostname you want to match. So a few of these are actually, in a way, shortcuts to other endpoints. This one's far more readable than /facts /blah blah with a query path. But when you're actually building it up programmatically in, for example, PuppetDB, building up the query is easier than essentially needing always to build up the API. Because we already have support for the facts endpoint, so instead of having to build out the nodes endpoint more, we can just wrap to the facts endpoint, which by itself will then again use the shortcut. There is one extremely weird thing about the PuppetDB API. That's the resources endpoint. As useful as it is, it's got this really weird quirk where you need to use a capital for the user type. If I use users here with a lowercase u, it'll just go no. The reason, as far as I know, is that in Puppet you have the types that you declare, so a user, a file, a packaging, or catalog. But the instance of it is the capital representation of it. So if you want to put a relationship and say, like, I require this file, you use the capital F file, and then the square brackets, the name of the resource. I'm thinking that's where it came from. I've actually been meaning to get this fixed in PuppetDB since like last year PuppetConf. But yeah, time and closure and things, and yeah, so many things you want to do. If you want to run or use the PuppetDB API, if you're using Python, my library is called PyPuppetDB. It's up on GitHub. Everything is up on GitHub. It's in the Nedap namespace. Essentially, it just allows you to connect to PuppetDB. You give it some information like your hostname, your port, the certificates to use if you need certificates, and it'll do the things for you. It offers you a bunch of objects, like the node object, that you can just use, like, give me a node, and you can go, like, give me the facts for this node, give me the reports for this node. You can query for facts, reports, not catalogs, because you don't really have any kind of use case for it yet, but we can add it. Or you can just use a freeform query and do whatever the fuck you want, and good luck. At FOSDEM last year, I got together with Deepak, one of the original authors and brain masters, I don't know, evil person puppet thing, behind PuppetDB. And we tried to write a closure version because the whole thing is in closure, but we didn't actually have a closure library, which is sort of ironic. So there's PuppetDB client. It's fairly old because we haven't really touched it for 6 months, but it still works, which is really super cool. And it's like 30 lines of closure max, and you get basically the whole PuppetDB API supported. Ken Barber, one of the current authors, maintainers, coders, wrote a Go client, basically because he wanted to write something in Go, and he figured, what the hell, why not? So there's a PuppetDB client for Go. I have no idea how maintained it is, how far it works, but you can use it, and it's probably fairly easy to patch if something breaks. Eric Dahlen from Spotify wrote PuppetDB query, which was at first a Ruby thing that you wrote, and he eventually also wrote a Node.js, eek, but fine, version of it. Now, the extremely cool thing of this is that because it's Node.js and JavaScript, you can actually hook it into your web applications. So one of the updates for Puppetboard will actually allow you to use the PuppetDB query syntax to go like, hey, I'm looking for a node with this class, instead of needing to write out the whole AST. What it'll basically do for you is you write the simple query, it parses it, translates it, and submits the complete AST. You can actually copy-paste it. You can even use it as a generator for your own scripts if you want to. Now, that's basically how you can use the PuppetDB API, but a lot of people haven't realized really what you can do with it, because the Puppetboard or Eric's Puppet Explorer, or heck, even the P console, basically what we're really doing is giving you a view on that data, but we're not really using that data to do anything extremely interesting with it. But if you think about it, it holds a crap load of information about your infrastructure. It holds users' accounts, in my case. It holds host records. It holds DNS rules, firewall rules, all the files I manage, package services, a whole bunch of things. So what if we could use PuppetDB to automate other parts of your infrastructure based on the fact that we know so much about your infrastructure? What if we could generate bind zone files based on the fact that we have nodes in PuppetDB and we have facts about them, which is really cool because whenever a node joins your family, cluster, whatever you want, you get the entry in bind, and the second you decommission the node, it's gone just as well. So the first thing we actually built at Nedap is a bridge for Django. It's an authentication provider in Django, which uses PuppetDB to talk to PuppetDB and to fetch the user resources that are in PuppetDB to allow people to authenticate. So everyone that has an account with us can use that account to authenticate to a bunch of web applications. So how this works is we need all the user resources that you might have. Now, if you're going to query on resources user for everyone, if you have 10 nodes, that's going to be a crap load of data, but it's pretty fast. If you have 1,000 nodes, that's going to be a crap load of data. It's going to be really slow, and you still need to sort through everyone. So the essential idea is that we have a few nodes that we call bastion nodes, nodes that everyone SSHs to get further on in the network. So what we do is we query for all user resources on that bastion node, and then when someone logs in, we just generate the hash from the password they send. We check it with the hash that PuppetDB has for this user, because in our case, we store that value in PuppetDB. If they match, you can move on. You can even set groups, and it will actually check if a user is a member of a certain Linux group to log into an application or not. So this essentially provides us a way of centralizing authentication, much like LDAP could do, but without the pain that LDAP is. And it has the really cool advantage that instead of having one application that has this authentication backend and one application that has that authentication backend, everyone can log in through the same system. It has also the really cool advantage that when PuppetDB is down, no one can do anything. Another really cool thing, or well, I think it's awesome, obviously, because I wrote it, but one of the kind of fun stuff you can do is, since you have resources, you can get them out. And you can do stuff with the fact that you have those resources. So how many people have tried to use Nagios, exported Nagios resources and collect them to do monitoring? There's 1, 2, 3, 4. OK, so how many of you have had to sit through Puppet runs that, because of it, end up from somewhere to 15 minutes to 1.5 hours? OK, so basically everyone. Great. So it's extremely annoying. We have the exact same issue. So what we ended up is with PuppetDB Stencil. What it does is you pass it on the command line an Nagios type to fetch for a host for whatever. And you pass it a template, in this case a Ginger template, which essentially goes, apply this template for every of those resources that you just fetched for me. So what this allows you to do is get all Nagios hosts, all Nagios service definitions, all Nagios anything definitions out of PuppetDB, apply it to a template, and generate your Nagios configuration. Now, if you think about it, it's sort of what the PuppetDB or what the Puppet templating thing does. So yes, we rebuilt a little part of Puppet, which is cool because we understand more about Puppet now. But it also has the extreme advantage that in our case, our runs went down from 1.5 hours to 2 minutes because we didn't have all the Nagios stuff that we needed to pull out of PuppetDB anymore, because that was just a cron job that ran every 5 minutes and just made sure that Nagios was there. Which is, in our case, an extreme improvement, because we were having issues where nodes were joining our system, and we're talking like 150 nodes. It's nothing. We've got people over here that have PuppetDB instances that hold 10,000 and more, like literally 10,000, 100,000 nodes. You just imagine the kind of pain you're going to have to go through if you need to download, or if you need to realize all those exported resources. And when you do that, it's just, the pain goes away. It's just great. You have the Nagios types. Nagios is one of the things you can do. DNS is another thing you can do, as I said before. What we have is a little system which essentially pulls out all nodes from PuppetDB, gets their IP address fact, and just generates bind zone files. A records, line, 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 reverse zone, pointer records, flush them in bind, and you're done. You can also hook this into deploy systems if you want to. There's no reason why you should necessarily have to wait on a certain timeout or wait until PuppetDB has the information. If you know what you're doing, you can essentially upload through the wire formats information into PuppetDB about a node before that node actually has first checked in from an agent. So if you have systems that depend on that, you can just pull the data out that you need, pull it in, essentially transforming PuppetDB into a sort of configuration management database. Be careful when you're doing that, because you really should know what you're doing. And you also need to be aware of that certain of those resources will expire after a certain point in time. So be careful. It's a powerful tool, but it's really cool, and it allows you to do a lot of stuff. I'm actually just going to go and do the crazy thing, which is code and demo kind of thing. Because I wanted to just jump into how this has all been. Oh, God, my screen's extended. Click where. Can anyone actually see where the mirror button went? Come on, work with me. Ta-da! There we go. Thank you so much. Oh, this isn't readable. Click. Can anyone see? Yes? Okay, great. So the basic premise, this is the Python library I wrote, is it currently supports v2 and v3 of the API. I don't know if anyone's had a look at v4. It's got a lot of cool stuff in there. We've got structured facts that are supported and a whole bunch of other things. But when I wrote PuppetDB, v2 was essentially the current API. v3 was the experimental thing. Now, v2 and v3 look a lot alike, so it was very easy to transition that over. v4 is more complex, so it's taken me a bit more time. But we'll get there eventually. So all it really comes down to, except for like all the cool stuff that automate a ginormous amount of stuff for you, is this fairly simple function. Essentially what it needs is basically, what the hell do you want to query? What's the path? Do we have an AST that we need to use? And a few other features. For example, do you want the reply ordered? Do we need a total? Can we summarize it? These are more of the advanced features that you have on the API. Like 80% of the time, you don't need the extra features, but they're extremely useful at times when you want them. And essentially, all this does, even though this looks fairly complex, is get a bunch of JSON back. So we query PuppetDB, and we try to do it smart, and it reuses the HTTPS session, etc., so that we're not handshaking every damn time and having the SSL round trips. We get the response from PuppetDB. We decode it. If it's empty, we raise an error for you. If it's not. And that's it. You can use this function, and you can query anything on the v2 or v3 API. Now, that's a fairly raw way to do it. So what we did is essentially, where did we go? Is have a bunch of functions that allow you to do far more useful things. So one of the first things you can do is just get nodes. So you call out for nodes, and you get what we call in Python a generator back. So instead of directly going and fetching things for you, it'll only start fetching it as you start iterating over the generator. This means that we can stream the output, which makes us better capable of handling big PuppetDB states, and you don't, it doesn't eat up all your memory at once. If you have 10,000 nodes, it kind of gets a bit of annoying. Now, we can do the same thing. You can get facts, you get the fact name endpoint, you get resources, whatever you want. So whatever we haven't implemented, you can actually implement yourself or just role query through the underquery attribute. Now, when we get a whole bunch of this information back for you, we decode them into objects. Because essentially, what we get back from PuppetDB is JSON. But when I get a JSON blob of a node back, like one of the most logical things I want to do is go node.facts and get my facts. Obviously, we can't do that. We can't just like send JSON back that goes node.facts and stuff happens. So we have a fairly big nodes endpoint, which does exactly that for you. Now, this might look a bit nasty, especially like things that consume iterators. But essentially, all it allows you to do is like give me a nodes, give me the facts, give me the so on, and so on and so on. And you can just chuck those in one after another and do things to it. And I think I actually had a little demo-y thing set up here. Yeah, there we go. So Eric at Spotify, who is working on Puppet Explorer, set up a public PuppetDB instance that we can use for testing of things. So essentially what this does is, for node in nodes, and for every fact in node.fact, return me all the facts. And then, it goes out, and you get a whole bunch of information. Now we've got, like, if you actually look at it, there are only like 3 nodes in it, but everyone has got a whole bunch of information. So you get the hostname of everything, their fact, and their value. Now this currently only supports the old style facts, so no structured data yet. We're getting to that, but it will. And this is like one of the easiest ways to get any kind of information from it. So essentially, if you wanted to get, I don't know, all of the IP addresses, all you need to do is just know what fact to query. So if I take, for example, where's my mouse? Doesn't matter. If you take p.node, in this case you can use a node, and it's I really do like my mouse sometimes. So if I took IP 172.168.102.eu west.compute.internal, don't shoot me. There we go. So I get a node object back. And if only I assigned it to a variable. And it has a bunch of things on it. So I can go a.fact, as family, almost. And hey, it's a Debian machine. And because we can do that, we can just as simply almost there get an IP address out. Ooh, I need to fix that bug. Love on live demos. So you can get the IP address out, and you can use this whole thing to build up templates to do basically anything you want. All that data is there for you. So my basic advice is just go crazy. Try and figure out in which places you have duplicate data, because one of the things we notice is we have things in our configuration management database, we have things in Hyra, we have things in PuppetDB, we have things everywhere. And a lot of the time you can consolidate that to one place and then just generate the rest of the stuff. So we have scripts that pull from PuppetDB that generate all kinds of information, our zone files, that generate Nagios configuration, that, well, essentially use a central authentication backend, and so on and so on and so on, which means that everything has the same source of truth. So you don't get the system where, oh, hey, I can log in here, but I can't log in here. And why is that? Well, your account hasn't been activated there, but it was there. But the process we have in place when we onboard people should have activated you there. There's no disparity anymore. You have one source of truth, and that's the thing you query. Now, there is one fairly important thing to keep in mind when you're using the PuppetDB API for anything like this, is PuppetDB doesn't know anything until it knows. Now that might seem like a fairly obvious thing, like, hey, if it doesn't have the data, it doesn't have the data, which, yeah, right? But it's important to keep in mind, if you have systems in place that, for example, that you redo often, like DNS or something, if you need that value to exist for your provisioning system, you can't ask it from PuppetDB until it's been in PuppetDB. So you need to either push that value into PuppetDB or have your provisioning system take care of that somehow. There's a few of these catch-22 loops that you'll run into if you try to do anything with the API. Once you work them out, though, it's really cool. You can do a lot of amazing stuff. Puppetboard is one of the examples that I have. Can't do the live demo here, which is a bit unfortunate, but seeing how good this went, I think I'm just going to stick with that. But essentially, it's do things with it. It has a lot of potential. You can do a lot of things with it. You can do a lot of crazy things with it. And you'll actually find it a very easy system to work with. Essentially what you're doing is just HTTP calls which give you JSON back. Now, if you've ever developed anything against a web API the past year, 2, 3, this is essentially what you've been doing for a lot of the time. If you're talking to the GitHub API, to Travis, to my mic, there we go, to anything really, this is how we've been working, this is how we've been building, so there's nothing really surprising over there. One of the really cool things that you can hopefully do, or that we can hopefully do shortly, is that PuppetDB will not only store the catalogs, but it will start storing historical data for us. So what we'll be able to do is build interfaces or even build scripts where over time you can see the evolution of a system. You can see that we're starting to manage certain resources, that we stopped managing certain resources, which mostly happens by accident because people forgot to clean something up, or that certain resources now have changed in value. There's a lot of really cool things that you can do with that. You can alert on that. You can use it for any kind of auditing purposes, because you can clearly see the evolution of a system. You know what's happened and what is currently being changed to it. I've got about 8 and something minutes left on the little clocky thing here. So what I was actually hoping to is get to a point where you're going to just fire questions at me about how do you do anything with the PuppetDB API, or do you think we can do this? So with that, we're going to move to questions. Sorry, is there any way we can dim the lights just a tiny bit? Go ahead.
I was wondering whether, if you found, like, in your use of it, whether it's a better policy to grab as much information from PuppetDB and then sort through it on the client or whatever is processing it, or do you just make very short requests and then combine it all later?
OK, so the question is it faster or better, or do you do a bigger query that gets more data from PuppetDB, or do you do multiple little queries that you then, on the client side, combine into whatever you want to do? And it depends a bit. Like, when you ask PuppetDB for data, especially if you have a very broad query, you can just, essentially, you can query for something that will just give you all the data that PuppetDB holds back. So that's generally not a good idea. So I always start by trying to scope the request, at least partially. But there are places where we actually go more for a dragnet approach, because it's easier to get all that data in and then sort through it manually than build up the crazy ASD query thing that will get you exactly the information you want. Now, with the whole ASD language changing, that'll likely change. And performance-wise, PuppetDB and PostgreSQL are generally a lot faster than whatever I can do in Python in my command line. So if you can build a more specific query, even if it's 2 specific queries, and then merge the data, depending on how much data you have, so essentially depending on your population, that might be faster than just going for the dragnet approach. Yep, on the back. I'll get to you in a minute.
Does PuppetDB persist to disk at all when it goes down?
Yes. So the question is, does PuppetDB persist to disk? Yes, it does. So PuppetDB is essentially this little thing that runs on the JVM. The Puppet master, or in case of standalone, just talks to PuppetDB. And then PuppetDB talks to one or multiple of its PostgreSQL database backends. So as long as there isn't anything preventing PuppetDB from just talking to Postgres, it persists whatever you're throwing at it on disk through PostgreSQL.
Cool. Thank you.
You're welcome. Go ahead.
You mentioned that PuppetDB will keep a history. Is that a future enhancement being made to it?
Yes. So the question is, the PuppetDB history, is that a future enhancement or is that something current? So right now, in a lot of places, what happens is when we get new data about a node, we just burn the old data away. We just remove it and shove the new data in. So the only place where we have sort of historical data are the reports, because that's the only one that currently really makes sense to store. Like, you want to be able to see at least n+1 reports that you get the differential of, like, hey, this worked, now it's broken, what the hell happened? The idea is that we're going to start storing more and more, hopefully, historical data into PuppetDB, especially also the evolution of your catalog, which will allow you to actually get diffs from different points in time of how your catalog looked and essentially how your machine was supposed to look like. Yeah, in the back.
I like your method, especially, I guess, with the
Yeah.
So my only concern is, as far as I can tell, like, when you do this, though, you don't benefit from the sort of elegant using the exported types and collection resources in your code, instead of putting that logic separately.
Mm-hmm.
Would it not be better to somehow fix the performance issues with exported resources and make that faster somehow?
Okay, so the
Logic where it should be?
yeah, so the question is, I've actually moved a part of the logic that we would normally do in Puppet, so the Nagios types, out of Puppet because of the performance. And wouldn't it be a better thing to fix the performance so we can keep the logic in one place? I completely agree. I would love to. However, I don't know how familiar you are with especially the Nagios types, because for most other resources, it's fine. It actually works, and you can do it just fine. But sometimes you just have other systems that are in control, or in my case, I sometimes generate SQL stuff to upload a PGSQL, to update a Power DNS instance. In the specific case of the Nagios types, their performance are just dreadful across the board. It doesn't matter if you use the exported version or not, and they have a lot of very nasty corner cases. So what we started to do on, what is it today, Tuesday? Monday, so yesterday, is we've started an effort to pull the Nagios types out of PuppetDB, or out of PuppetDB, Jesus, out of Puppet itself. It's in the hope that we can actually get people in that maybe know Nagios better, that have a better feel of how the thing works, that we can fix the Nagios types so that it becomes feasible, especially in large environments, to once again have your Nagios types and exported resources in your catalog and be able to reason about it and put relationships on them. Until that time, depending on the size of your environment, you're just going to have to figure out what you want. If it's tolerable for you to have Nagios machines and have a half-hour Puppet run, then by all means leave them in. If it gets to the point where you just can't anymore, then for now your only option is to pull them out. We're working on trying to fix this thing as a community, but it's also going to depend a lot on how many people are willing to put in the effort to fix Nagios types, and also how much the new Ikinga Nagios object model is going to take off, and maybe see more and more people transition to that, and then we'll just let the Nagios types die a slow, or well, hopefully a fast death.
Can you just expand on that what you're planning to fix on it?
Right now, I have absolutely no clue. So what we've actually done is just pull them out so that we can actually work on them separately from the Puppet core release cycle. How we're actually going to fix the performance issues, I'm unsure. We're going to try, we're going to look, we're going to see and figure out if we can get the whole Naginator thing and the parser that there's a nasty little parser and compiler separate for it, about it, and see what we can do about that. But I have no plan nor any kind of guarantees that I can make that we're actually going to be able to solve this issue. I think it's your turn.
Does Puppetboard handle talking to multiple PuppetDB instances?
No, it does not. So right now it talks to a single instance, but it should be fairly trivial to add that. Does anyone see anyone waving? Because I'm kind of lost here.
Yeah.
OK, go ahead.
You say that a future version of PuppetDB will be able to store history and track changes. Do you know offhand when that might arrive?
No, Deepak mentioned it today in his talk, as in this is stuff we're working on for the current year. Or, well, not essentially the current year, but what we want to work on from here until the next PuppetConf. We've already been talking about how this is going to do. Like, I don't work for Puppet Lab, so I'm basically, most of my input is generally how the API should kind of work and feel, because I'm one of the people that use the API the most because of Puppetboard. But we've had some pretty good ideas on how to do it, how to store the differential, and essentially, sorry, maybe try and merge or annotate the catalog so that we, based on the catalog, can sort of generate the report that goes with it and back and forth. So I don't know when it's going to land, but I expect that work's going to start on it fairly soon. Anyone else? Just shoot. I can barely see anything from here. Hi.
Listen to the voice.
Yeah.
Would it be terrible to offer a thought as a possible workaround?
No, go ahead.
One thing you could do, maybe you could try and see if it's true, is you could actually replace the standard Nagios
Mhm.
You'd have them create on the local machine file stubs that would be sort of like the place where what would happen.
Mhm.
Take those, feed them into the fact, put that fact data into one super type that you export, and each host only has one thing it has to export from. So you have a combined thing, which then on the Nagio server gets breaking up and used. So you still have one exported resource per host.
Mhm.
Only will have one, and that should probably help you performance a lot.
Yeah. So the suggestion that was made is to, instead of trying to fix the Nagios types, just go for it another way around. So where one machine just exports all its configuration or its Nagios related configuration in one resource in one go, and collect that on the master. And then you only have like one resource per machine. It's a fairly big resource, but maybe it should be possible. Right now, what I've seen is that people have started to use the concat modules to essentially do the same thing. So they export concat fragments, which are then aggregated on the master and in turn generate the Nagios stuff. That works. It's got a better performance than using the Nagios types through PuppetDB, but it's still not as fast as could be. So we're definitely up for suggestions as far as that goes. So I'll keep it in mind. Thank you. I think we're through time here. So I don't know if there's like one more question that we can quickly get to. I don't hear any voices. Not in my head, not from here. OK, then I think that's going to be it. Thank you so much.